Hello. This time, let's make Python code more general Hohenly model. So let's start. First, let's import some useful. Let's import some useful packages. So the usual ones: import numpy, snp, and then from tabulate import tabulate, and then exponential and square root. From math, import square root function and exponential function. And then we will use optimizer. So from scipy optimize, import minimize. I made separate YouTube video for this scipy optimization, but let me briefly introduce this one. Let me explain very briefly. So suppose we have this kind of function. We have a function such that um, yes, have x1, x2. This function has two arguments like this. And then this is the x1 minus c1 square plus x2 minus c2 square. We want to find the minimum value of this one. And then let's add 99. Okay. And then let's minimize this one. And we know the minimum value occurs when C1 is X1 is C1 and C2 X2 is C2. Okay, let me make it simpler. So this is 1 and this is 2. Okay, then clearly the minimum occurs when X1 is 1, X2 equals 2. And then control MB. Okay, so make another code. So let's define my function. Here, input is X. Okay, input is X. And then we will return part 1 square plus part 2 square plus 99. And here, of course, part 1 equals x1 minus 1. And part 2 is x2. Remember, Python starts from 0, so minus 2. And then we want to minimize this one. And then we want temp equal minimize my function. And then we have to put initial guess. Okay, we have to initial guess. Initial guess, let's make a very wild guess, 10, and then 10. Okay. This wild guess, we know the correct answer 1 and 2. So they're clearly wild guess, very wrong. But this find solution. So here, so okay, functional minimum value occurs, the minimized value is 99, and the minimum value is, this is 1 and 2. Not exactly 1 and not exactly 2, but very close enough. Here, actually, yeah, let's print. Always I put print. And then here, I didn't use any optimization method, but we can add optimization method. My favorite optimization method is LPFGS. So I use this optimizer. So basically the answer is the same. Okay. And then let's make it slightly more general. So instead of 1 and 2, let's make it to the C1, C2. Okay. So C1, C2, this is now something I have to determine first. Okay. So I have to pass through this value. So here, C0, C1. Okay. And then here, clearly, I have to determine C, this one first. Okay, so I pass through these predetermined values using argument args. Argument equals, let's say, C parameter, and then here C parameter is 1, 2. If we run it, we have the same one. But here now I pass through these parameters over here. Actually, I can make another parameter. So let's make now one minus T1 minus D2. And here, this one becomes minimized when x1 equals C1 plus D1 and D2 equals C2 plus D2. So I have to pass through another one. Let's make it D. So and then here minus D0, and here minus D1. Okay, same. Now I have to pass the D parameter. Let's say this is 100 and this is 200. And then the argument I have to pass through another one, D parameter. Okay, so again, the minimization occurs, minimize the function 99, and then the minimum value occurs when x1 is 101 and x2 equals 202. Okay, so I think it is good exercise for minimization. And then let's go to the Holy model directly. So let's start from our input value. So R0 0.0994491. Okay, 4 actually 9 1, and then R1. I'm using exactly same one as before. Okay, exactly the same one. I'm saving. And then DT is of course 3 months. And the volatility is 0.0005, 0.5%. Therefore, our bond price becomes the set of bond price is of course 100 multiplied by EXP minus R0 DT, because in our previous problem, it was the 6 months bond. So multiply 2. And the second bond was in our previous example, it was 9 months bond. So I multiply 3. And then I use this interest rate. Okay. And then the drift term. The first interest rate was drift term should be 0. Start from beginning. Second one is 0.0003, something like that. And then next one was 0.005. Okay, something like. Let's reduce this one. 0, this one mu. So they are the drift term. The first one is this one itself, so I intentionally put 0 over here. Okay, and then let's t now. T, because we have up to 3 periods, 3 months by 3, so 9 months. So t equals 3. Okay, they are the input values. Now let's create our interest rate tree. So let's call the interest rate tree as race. And then let's first fill this one with zeros. And then we have 3 by 3. Oh, actually t by t matrix. And then if we, the output looks like this. So tabulate, print, tabulate. Okay, like this. Everything is 0. And I want to fill this one with interest rate. So this time, let's make it more general. So to make it more general, let's make it a for loop. Okay, for loop in Python. So for I in range from 0 to t. Okay, this is for loop. So for example, to illustrate for loop, I can print I. Then when I moves from 0 to t, it print out. So it print out 0, 1, 2. Okay, 0. This last one, t equals 3. So the last one is always not included. Okay, so it works this way. And then what we can do is, of course, the first element. If what we can do is from Ho and Lee model, we have raised because we have to put the bottom first. We want to fill this one first. So bottom one is when I equal 1, it should be bottom. So t minus 1, right? The next one is t minus 2, I raise, okay, t minus 3. Then this is the first row. So this is the bottom row. This is the middle row. This is the top row, okay? So we fill bottom row first, and by adding 2 times the volatility of square root dt, I can generate this one and this one. And this one is, of course, equal the previous one. Oops, what is going on? Okay, this one, previous one. Oh man, again, copy. Okay, and then I minus 1 plus now m mu I multiplied by dt, and then plus minus, of course, because we will making the bottom, so always minus volatility multiplied by square root of the dt. And these ones are Okay, this one now plus 2 times of volatility and square root, right? And then now we have the same one, but instead of this one, I have to use this one. So now minus 2, because the next bottom one, I want to add this stuff, okay? So if we run it, well, this is something's not right because, right, because we don't have R0, okay? So if I equal 0, I is greater than this one, then this is right, else this one should be, here the initial one is R0, right? And then if we run it, else, okay, I need this one. So, well, this one is now, the very first one is, the very first one, this one should be same to this one. So clearly there is an error in the code. There is a clearly error in the code, okay? So where is the error, okay? Where is the error, okay? R0 mu first one is 0, and then this is, I have to multiply I. Okay, the first one is, of course, this one. Okay, bottom line. And then this one. So I think now this is right, because here I add R0 and then I T bottom 0 mu now 1 and volatility and then go back to 0. So I just generated the first one. 네, interest rate. I fill the interest rate as follows. Yes,